This is MSJ Chem. In this video, I'll be looking at the addition reactions of the alkenes. Alkenes are reactive molecules due to the presence of a carbon-to-carbon double bond, also known as an alkenyl group. They undergo electrophilic addition reactions in which two molecules combine to produce a larger molecule. Here we have examples of symmetrical alkenes. We have ethene on the left, but2-ene in the middle, and on the right we have hex3-ene. As we can see, each molecule has a carbon-to-carbon double bond, which is the reactive part of the molecule. When alkenes undergo addition reactions, the carbon-to-carbon double bond opens up, creating additional bonding positions. We'll look at the difference between symmetrical and unsymmetrical alkenes at the end of the video. The first type of addition reaction we look at is hydrogenation. In this reaction, an alkene reacts with hydrogen to form an alkane. So here we can see C2H4, which is ethene, reacting with hydrogen to form C2H6, which is ethane. In the reaction, the carbon-to-carbon double bond opens up and we add two hydrogen atoms to the molecule. Note that this reaction is usually carried out using a nickel catalyst. And here we can see the overall chemical equation for the reaction. The next type of reaction is halogenation. In halogenation, alkenes react with halogens to produce dihalogeno compounds. So here we have ethene reacting with bromine to produce 1,2-dibromoethane. And here we have the chemical equation for the reaction. Alkenes also react with hydrogen halides, that's HCl, HBr or HI, to produce halogenoalkanes. So here we have the reaction of ethene with hydrogen bromide to produce bromoethane. And once again, here we have the chemical equation for the reaction. The next type of reaction is hydration, in which an alkene reacts with steam to form an alcohol. So in this reaction we have ethene reacting with water in the form of steam in the presence of a sulfuric acid catalyst to form ethanol. And here we have the equation for the reaction. And finally, we look at the difference between the reactions of symmetrical and unsymmetrical alkenes. The addition reactions of symmetrical alkenes produce only one possible product. So here we have but2-ene, which is a symmetrical alkene reacting with hydrogen chloride. The only possible product of the reaction is 2-chlorobutane. Next, we have the reaction of but1-ene, which is an unsymmetrical alkene. When but1-ene reacts with hydrogen chloride, there are two possible products. They are 1-chlorobutane and 2-chlorobutane. To predict the major product of the reaction, we apply Markovnikov's rule, which is only covered in the higher level syllabus. For higher level students, in this case, the major product will be 2-chlorobutane. This is due to the stability of the secondary carbocation.